The sum of the measures of the angles of any triangle is 180 degrees. Let's say that we have a triangle where two of the angles are given 136 degrees in 50 minutes, 41 degrees in 38 minutes. We want to find the measure of the third angle. Well, we know that if we take the existing angles and add them together, the one that we don't know, let's call that x. We know that if we total up the sum of all three angles, we will end up with 180 degrees. So let's solve for that third angle x. So we will add these two angle measures together. We can come to the side here and line them up vertically, just like we did in the last section. And then add together. So we get 8 here and 8 here, so 88 minutes and 177 degrees. Let's write this a little nicer. Instead of writing it as 88 minutes, we know that 60 minutes makes up one whole degree. So let's borrow or take away 60 minutes and convert that to be equal to 1 degree. So we really have 178 degrees, and that gives us 28 minutes. So we have 178 degrees, 28 minutes, plus x is equal to 180 degrees. So now we need to subtract from both sides 178 degrees, 28 minutes, and that'll give us our value for x. So we need to subtract. We can't subtract 28 minutes from nothing, so let's borrow. Let's make this 179 degrees, and let's borrow 1 degree and represent that as 60 minutes. So we'll write it as 60 minutes. Now we can actually subtract 28 from 60, and 28 from 60 will give us 32 minutes. And then 179 minus 178, that gives us 1 degree. So the answer for that third angle that we didn't know would be 1 degree and 32 minutes. Similar triangles are triangles that have exactly the same shape, meaning all the same angles, but not necessarily the same size. The sides themselves could be longer or shorter. We're basically scaling some triangles. So similar triangles have all the same angle measures, but maybe have different lengths of sides. When we look at these two triangles, we see that the ones that have the angles that have one circle or one curve mark, these would be corresponding angles. These have exactly the same measure. If we have two curve marks, that represents these two angles having exactly the same measure. And lastly, we have 3 curve marks, and 3 curve marks would imply that those have exactly the same measure as well. So angle A is equal to angle D. Angle B corresponds and equal to angle E, and angle C corresponds equal to angle F. And when we have similar triangles, when they have the same angles, their sides will be proportional. So their corresponding sides would be proportional. So where do I have corresponding sides? Well, we want to orient our triangles so that all the angles are in the same position in both triangles. So side AB would correspond to side DE. So 10 is to 20 as, so their sides must be proportional to each other. So that means that if when I look at side BC, that would correspond to side EF. So 6 is to 12. And lastly, side AC would correspond and be proportional to side DF. So 7 corresponds to 14. When we talk about proportional, we mean that if I were to form fractions of all of the corresponding sides, that all of these fractions would be equivalent to each other. So all of these fractions reduce to be 1/2. So a triangle DEF is actually multiplied by 2, scaled by a factor of 2, when we look at how it corresponds to a triangle ABC. And vice versa, triangle ABC is half, scaled by a factor of 1/2 of triangle DEF. And next we want to look at two similar triangles, and we want to find the unknown angle measures in both pair of triangles. We see that their angles are slightly off. They're kind of mirrored, similar triangles, but they both have a 90-degree angle, so that implies a right angle. They both have a 90-degree angle, and they have one curved mark here and here, so that would imply that this would be the same measure of 42 degrees. So what would be the remaining corresponding angle? Now, if these two are the same and these two are the same, then the remaining angle would have to be exactly the same measure as well. So we have 42 degrees plus 90 degrees, and that gives us 132 degrees. So what we have so far is a total angle measure of 132 degrees. So we have 132 plus the unknown angle. Let's solve for B, since they're the same. So we have 132, when we add these two angles up, plus angle B, of course we know that the sum of all of the angles has to be equal to 180 degrees. So let's subtract 132 from both sides. So we get that B has a total angle measure of 48 degrees. And also implies, if this is 48 degrees, that the similar triangle QRP would have an angle R of 48 degrees. Okay, here we want to find the lengths of the unknown sides. So we're going to, first of all, look at where our corresponding angles are. So we have two angle measure lines, and that would imply that those are the same angle. And we have one here and one here, so those are the same angle. And of course the remaining one would have to be equal as well. So they are oriented in the same way. So we can say corresponding sides, A is to 10, so A over 10 should be equal to 75 over 25. Now when we set these fractions equal to each other and we're going to solve, we want to have an equation like this that only has one unknown. So we're going to solve, we're going to cross multiply. We have 75 times 10, that would be 750. And then 25 times a, and then we're going to solve for a by dividing both sides by 25. So we get that a, when we reduce this, we get 30. A is equal to 30. Now we want to find the measure for b. So for b, we have to find our corresponding sides. B is to 20, so B divided by 20, those are corresponding sides, would be equal to, and we can use 75 and 25 again. Same thing as 75 divided by 25. And then we can cross multiply. 75 times 20, I get 1500 is equal to 25 times b, and then we divide both sides by 25. 25 goes into 1560 times. So our measure of side b would be 60. So we have 60 here and 30 here. And as we look and compare the numbers, we see that we have a scaling factor of 3 or of 1/3, depending upon which triangle we start at and which triangle we go to. So in triangle AB, or the first triangle, the larger triangle, that is 3, each one of those is 3 times larger than all of the sides in the smaller triangle. Alright, our last problem here. We have a lighthouse. A little bit of a word problem here. The Biloxi Lighthouse in the figure casts a shadow that is 28 meters long at 7 p.m. At the same time, the shadow of the lighthouse keeper, who is 1.75 meters tall, his shadow is 3.5 meters long. We want to know how tall is the lighthouse. Now the idea of both being at the same time, that same angle, means that as we go to form those triangles, we have our lighthouse and we have the shadow, and if I go from the top of the lighthouse to the tip of the shadow, we form a triangle. In this angle, of course this is a right angle, but these two angles would correspond to the same triangle, be the similar triangle to the keeper of the lighthouse. So if I draw a little line from the top of the keeper's head to the tip of the shadow, we form a 90-degree angle there, so they're both right triangles. And the fact that they're both happening at 7 p.m. implies that the angles of those triangles would be the same. So these are similar triangles. So let's go ahead and draw our similar triangles over here. So it says that the lighthouse, well, we don't know how tall the lighthouse is, that's what we're trying to find, so let's call that height. Let's call that height x. And the shadow is 28 meters long. And this angle, we'll give that 2 tick marks. This is 90 degrees, and we'll give this 1 tick mark. And this is our lighthouse. Now you have a little tiny triangle formed by the keeper of the lighthouse, also 90 degrees. And his shadow was 3.5 meters long, and we also know that he is 1.75 meters tall. So we have enough information here, because of the fact that they both happen at the same time, to see that we have similar triangles, and we can form a ratio of their corresponding sides to solve for x, the height of the lighthouse. So let's set up our ratio. X would correspond to 1.75. So x is to 1.75 meters as, now the other corresponding sides, 28 meters over 3.5 meters. And once again, as we go to solve this, we will cross multiply 28 times 1.75. We can put that into our calculator, and I get 49 equals, and then x times 3.5, we get 3.5 times x. And solving for x, we're going to divide both sides by 3.5. And once again, we can put that into our calculator, and we find that x is equal to 14 meters. So the height of our lighthouse would be 14 meters tall.